Great day. Wait, you hear that? We're getting to that time of year again. I am so excited. No, not Christmas. No, not New Year's. It's Labmas. Once again, ladies and gentlemen, great day. It's awesome to see each and every one of you. And today begins our Labmas celebration. And I am so excited. This is my favorite time of the year. Now, if you don't know what Labmas is, definitely check out one of my playlists before. It's called Labmas, and it's 12 days of experiments. Now, we're only going to do about 8 days of experiments here because of the time restrictions, but I am so excited. Every day is going to be a new lab. Now, some days our experiments are going to be tough. Some days our experiments are going to be super easy, but either way, we're going to enjoy and celebrate Labmas by sharing the love of science, and I just cannot wait to see some of the experiments that we are going to do over the next few weeks. Now, for our first day of Labmas, I kind of want to talk a little bit about safety. Now, for all of these experiments that we do, safety is so important. So we should definitely have our safety gear as well as anything else that's going to protect us. Now, we need to keep an eye on some of our experiments too, because some of the experiments we are going to do take a day or two, and we need to keep an eye on them that they're not disturbed or damaged. So in the spirit of Labmas and in the spirit of safety, what I want to focus on today is fire. Now, we all know what fire is. It is one of those forms of heat energy. Now, if you remember the 3 forms of heat energy, we have radiation, which comes from comes from the sun. We have conduction, which is a heat transfer by touching. And we have a convection, which is a heat energy that passes through the air or water. And that's important to know, but when we're dealing with fire, we need to know that fire, first of all, yes, it can keep us warm, it can cook our food for us. There are a lot of good things about fire, but for the most part, ladies and gentlemen, fire can be destructive. So we want to do whatever we can to fight fires. So what I wanted to do, because, when I was your age, ladies and gentlemen, being a teacher isn't what Mr. Sargent had in mind. I wanted to be a fire engine. No, I didn't want to be a firefighter. I wanted to be the fire engine. I just thought they were the coolest thing in the world. And I was obsessed with fire engines. But as I got older, I realized the true heroes are the firefighters that are inside the fire engine. Now, their job is to keep us safe and to put out fires. So what I want to do today is first introduce all of this lesson with an epic book called Fighting Fires. So sit back and let's listen.
Firefighters risk their lives to put out fires and save other people's lives. Long ago, people passed buckets of water by hand to put out fires. Now, when an alarm sounds, firefighters have many kinds of special trucks to help them. Pumper trucks carry water, hoses, and a pump. In just 1 minute, pumpers can shoot out 1,250 gallons of water. That's enough water to fill 50 bathtubs. Many pumper trucks also make bubbly foam that puts out oil fires. Some pumper trucks carry a long crane called a boom. Firefighters stand inside a large bucket and are raised 100 feet into the air to pump water or foam on a fire. Ladder trucks help rescue people who are trapped inside burning buildings. The ladder on top of the truck can reach 100 feet above the ground. Tiller trucks are 2 ladder trucks that are joined together. One driver steers the front and a tiller driver steers the back. Two drivers makes it easier for the big truck to get through narrow city streets. Quint trucks do the work of both pumper and ladder trucks. A quint truck has a pump, a water tank, hoses, and two kinds of ladders. Searchlight trucks are used to light up dark, smoky fires so firefighters can see. The truck's 8 spotlights are bright enough to light a sports stadium at night. Rescue trucks carry tools for emergencies, including special suits for walking through fire. Rescue trucks also use the jaws of life to help remove people from crushed cars or collapsed buildings. Aircraft crash rescue vehicles carry as much as 2,500 gallons of water. That's because an airplane crash may be a long way from a water supply. A crash rescue vehicle can put out an airplane fire in minutes. Off-road fire trucks are used to fight forest fires and brush fires. They carry water, foam, hoses, and pumps. Off-road fire trucks need to be tough enough to drive in places where there are no roads. Special helicopters drop water from 100-gallon buckets onto forest fires. A huge bucket scoops up water from a lake for the next flight over the flames. Smoke jumpers are firefighters who parachute from airplanes. Their work is very dangerous. They have no way to escape if the wind shifts and the wildfire burns toward them. Fireboats put out fires on ships or in waterfront buildings. A fireboat does not carry water. It takes it from beneath the boat. A big fireboat can pump as much water as 10 pumper trucks. Special trucks, boats, and aircraft help us fight fires.
Wow, I didn't know there was that many ways to fight fires. Well, today we're going to test one of these methods. Now, if you notice, one of the things that was mentioned was the foam. Now, this foam isn't just normal foam. It is the result of a chemical reaction. And because of this chemical reaction, well, it actually puts out fires. And I want to see if we can duplicate and replicate this foam or this gas. We might not make the foam, but we'll definitely make the gas to put out a fire. But before we do anything, we need to get to the lab and get in the right gear. So we're in the lab, ladies and gentlemen. I got the Science-Tron 10,000 with our question already up there. I have my materials right here. I'm missing something. Our focus today was about safety. Am I being very safe right now? No. So let's get in the right gear. Much better. I have my safety goggles and I have my lab coat for any spillage. Now, it's important to understand that whenever doing an experiment, especially an experiment dealing with fire, you have to have parent permission and parent supervision. They need to be there doing this with you if this is an experiment you want to try at home. But what we want to see today is, well, we want to answer our question. How can we put out a fire with a chemical reaction? Now, our hypothesis is, well, I think we can because, well, it wouldn't be Labmas without our experiments being a success. So, if we look at the next, we're going to talk about research. Now, to do this, we need to understand the power of fire and what fuels a fire. All right? Now, first of all, this is a fire. It feeds off of something called oxygen. Well, you guys know what oxygen is. We breathe it as well. The fire uses oxygen to grow stronger and it fuels the fire. So, in order for us to sort of defeat the fire and put out the fire, we need to, well, take out the oxygen. How do we take the oxygen out of the air? Well, ladies and gentlemen, with science and a chemical reaction. So to do this experiment, you only need a few simple materials. First thing, you need a candle. And, well, I need some fire, but it's not burning yet, so... there we go. It worked. So I have my candle lit. I have some containers, because we're going to see which container works the best. And then we need something to make our chemical reaction. Now, a few weeks ago, we did an experiment where we filled a balloon with, well, carbon dioxide. Now, carbon dioxide is not oxygen, is it? But it's the byproduct of a chemical reaction when you mix an acid, in this case, vinegar, with baking soda, which is a base. When you mix these two together, we get a chemical reaction. Now, one thing that we learned by doing the experiment is carbon dioxide is heavier than oxygen, so it should sink. So what we need to do for this candle is find a way to create and move the carbon dioxide from one thing and put it over the container, thus starving the candle. Let's see if we can do it. So the first thing I'm going to do is I'm going to fill up both containers with some vinegar. And I'm not necessarily going to fill it. I'm just going to put about a cup of vinegar in each container. Now I'm doing this in these two different containers because with this container you should be able to see the reaction, and I'm not sure if the camera will catch the reaction from over here. All right, so our next thing that we need to do is we need to take our baking soda and create a chemical reaction. So let's see what happens. Now, if you notice, it is bubbling. It is creating a chemical reaction. When the baking soda mixes with the vinegar, it is causing it to change and react. And what's being created is, well, carbon dioxide. So we're gonna wait for that settles. Now, once it stops bubbling, if we take a look, it settles. It's almost unsettling. And what should have happened is it should have created carbon dioxide. Now, the carbon dioxide shouldn't escape from the container. It should still be in here. All right? So to show you just what I do, I have an empty container right here. If I pour it out, just the air, nothing happens to the flame, does it? No, it actually stays lit. Nothing happens with air because this is just filled with, well, normal air and oxygen. But if we dump out the containers here, now it should put out the fire. Now we're not going to put any liquid on the fire. We're just using gas. So let's see if it works. And look at that. It put out the fire so quick.
And look at that. It put out the fire so
quick. Did I pour any liquid out? No. What I did was I just poured the carbon dioxide and it starved the fire. Now, like we said before, ladies and gentlemen, firefighters use all sorts of tools and equipment and, well, chemical reactions to put out fires. This is just one of them. That foam that they were talking about using is filled with carbon dioxide, and what it does is it starves the fire so that the fire won't have anything to eat. It won't have any oxygen, will it? So it will die out, thus putting out the fire and saving the day. Well, ladies and gentlemen, I hope you enjoyed day 1 of Labmas, and day 2, cannot wait till tomorrow. We're going to be doing something super fun, having to deal with, oh my goodness, something Mr. Sargent doesn't like. We're going to be talking about snow tomorrow. So ladies and gentlemen, I hope you have a great night, and I cannot wait to see each and every one of you tomorrow.